Hello my dear children, once again welcome to our physics class. Hope you all are fine over there. Today let's discuss about the remaining concepts of this chapter, thermal properties of matter. So first we are going to discuss Venns displacement law. What do you mean by Venns displacement law? The product of wavelength corresponding to maximum energy and absolute temperature of black body is constant. That is Venns displacement law. So mathematically we can express Venns displacement law as follows. Lambda suffix m into T equal to a constant. That is the product of wavelength corresponding to maximum energy and the absolute temperature is constant. So lambda m is the wavelength carrying maximum energy and capital T is the absolute temperature. So product of wavelength carrying maximum energy and absolute temperature is constant. Now the value of this Venns constant is 2.9 into 10 raised to minus 3 millikelvin. Okay, so this constant is the Venns constant and the value of this Venns constant is 2.9 into 10 raised to minus 3 millikelvin. And this law explains why the color of a piece of iron heated in a hot flame first becomes dull red, then reddish yellow, and then finally white hot. Okay, so Venns law is useful for estimating the surface temperatures of moon, sun and other stars. If red and blue stars emit radiations of continuous wavelength, then blue star is hotter than red star. Okay, so if red and blue stars emit radiations of continuous wavelength, which will be more hotter? Those star which has minimum wavelength will be much hotter. Why? Because lambda m into T is a constant. That means lambda is inversely proportional to temperature. So when lambda decreases, temperature will be more. And when you compare blue and red color, which color has maximum wavelength? Yes, red color has maximum. For red color lambda is more and for blue color lambda is less. So when lambda is less, temperature will be more. So for blue color lambda is less, so temperature will be more. That is blue star will be hotter than the red star. Okay, so all this phenomenon can be explained on the basis of Venns displacement law. And next we can discuss Stefans Law. Stefans Law of radiation. Stefans Law states that the total radiant energy emitted per second from unit area of the surface of a black body is directly proportional to the fourth power of its absolute temperature. See, that means energy is directly proportional to fourth power of absolute temperature. So this is the mathematical expression of Stefans law, and this proportionality constant can be removed by adding this proportionality symbol is removed by adding a constant sigma. So sigma is the proportionality constant here, then the expression becomes E equal to sigma T raised to 4. So this is Stefans law. The total radiant energy emitted per second from unit area of a surface of a black body is directly proportional to fourth power of absolute temperature. Then Newton's law of cooling. So what is Newton's law of cooling? According to Newton's law of cooling, the rate of loss of heat is directly proportional to difference of temperature between the body and its surroundings. So mathematically we can express Newton's law as follows. dq by dt is equal to k into T2 minus T1. Okay, where T1 is the temperature of surrounding medium and T2 is the temperature of body. K is a constant that depends on the nature of surface and area of exposed surface. So, what is Newton's law of cooling? The rate of loss of heat is directly proportional to difference of temperature between the body and its surroundings. So, if you keep a hot cup of coffee for a long period of time, it gets cold. So that means the coffee has lost some of its heat to the surroundings. So the rate of loss of heat from this cup of coffee is equal to the difference of temperature between this cup and the surroundings. Okay, so that is Newton's law, and this is the mathematical expression for Newton's law of cooling. And this law is applicable for small temperature difference. That is the important point. This Newton's law of cooling is applicable for small temperature difference. And for small temperature difference, cooling occurs due to a combination of conduction, convection and radiation. The graph between difference in temperature and time is shown in that figure. Okay, so these are some of the important points that should be noted for Newton's laws of cooling. So children, with this I am concluding this chapter. Notes of the topic have been uploaded, please go through it. YouTube videos also have been uploaded, please go through it. We will meet in the next session with a new lesson. Till then, take care all of you. Stay home, stay safe. Thank you.